Welcome back. This is Math 181. This is section 4.1, related rates, and I'm getting ready to do number 2. And number 2 is air is being pumped into a spherical balloon so that its volume is increasing at a rate of 100 cubic meters per second. So think about a balloon being pumped, and you know the volume is increasing. Lots of things will be increasing. It's asking how fast is the radius of the balloon increasing at a particular diameter, and how fast is the surface area increasing when the diameter is 50. So these are two questions related to the above rate of 100 cubic centimeters per second. And notice it's cubic centimeters per second. That is a change in volume. It says this volume is increasing. So let me interpret what we have here. We have the sphere. Its dV dt is 100 cubic centimeters per second. Now let your variables dictate your units. So volume is cubic and time is in seconds. Now the question on A is, what is dr dt? How is the radius changing with respect to time when the diameter is 50? So the relationship between V and R, I'm going to use the 4/3 pi r cubed this time. And take the derivative. Your dV dt is equal to 4/3 pi as a constant times 3r squared dr dt. And I cancel the 3's and I got 4 pi r squared dr dt. And now there's the relationship. So I can substitute in how many unknowns are there, dV dt, r, and dr dt. And what they're asking is what's dr dt? So this one's the question, dr dt. And we know what r and dV dt are. dV dt up at the top is 100, so I'm plugging in 100 here. 4 pi, my r was given as 25 centimeters, and I'm looking for dr dt. Now, when I do this problem, these problems, I just substitute in left to right into the derivative instead of solving for dr dt and then substituting in. And I imagine that a lot of videos would solve for dr dt and then substitute in. And so what I do is I start simplifying here my dr dt, then I divide by all of that. Simplify, leaving pi, so you can do your 100 over 4 times 25 squared, and that's 1/25. And as a decimal, it's 0.0127, or 1 over 25 pi. I'm not sure exactly what WebAssign is going to ask for. Now let's look at the unit on this. I know that the decimal is 0.0127, and I'm looking at r with respect to t. Now what is r measured in? R is measured in centimeters, and time is measured in seconds. So this is going to be centimeters per second, right? So keep that in mind. I guess we could have substituted all the units in, but that gets a little messy. And now I'm just going to conclude the meaning is when the diameter is 50 centimeters, the radius is increasing by 0.0127 centimeters per second. And I believe that's correct. Let me double check that answer. Yeah, I think it's correct. Let me know if sometimes when I put that 0 in front of the decimal, I get incorrect. Yeah, that's fine. It's good. I did not double check that. Now, let's look at part B. Part B. It says, let's see what it says. It says, how fast is the surface area increasing when the diameter is 50 centimeters? Now, surface area, the area of a sphere is 4 pi r squared, and we're given again that the diameter is going to be 50 centimeters at that point. Radius will be 25 centimeters. So this one, just find the derivative, dA dt. I brought the 2 in front. I got 8 pi r dr dt. Substitute in the 25 and the 1 over 25 pi. I put that one in instead of the decimal, and things cancel nicely, the 25 and the pi, and it gave me a solid 8. Now the unit. The unit has to do with A and T. Area is measured in, what's it measured in? Centimeters squared, and this is in seconds. So this should be centimeters squared per second. And we have, when the diameter is 50 centimeters, the surface area is increasing by 8 square centimeters per second. All right, I'll come back for the next one.